Hi again, ladies. Here's part 2 of this video. I had to kind of abruptly cut off our video last time. Just something happened at home. It's not a big deal. But in the meantime, I actually ended up getting a new stylus. So hopefully you guys can read my writing a little bit better now. That'll be really exciting. So hopefully this video is a little bit easier to read. Okay, let's do the second part of our lesson. Okay, so just in case you took a break in between the two videos, we just talked about how to know whether a point is a solution to a system of equations. Okay, and now we are going to look at creating a system of equations by making equations from a word problem and also interpreting those equations. How do we know what they mean? Okay, so a couple instructions here. We are going to definitely want to choose variables to use. Okay, so those are our let statements that are so infamous with you guys for some reason. So those are our, oh boy, there we go, let statements, if you need to make that note for yourself, and of course I will be showing you that in our examples. And then the second is that we're going to use the information in the word problems to create two equations, and the reason I put the word distinct in there is to tell you that they're two equations that are different from each other. Okay, that's what the word distinct means in math, something that is not the same, okay, that relate, of course, to the two variables we chose in the first part. All right, so let's start here with this first example. Adelie is 2 years older than Everett. 1 year ago, Adelie was twice Everett's age. Create a system of equations to model the situation. Now, before we actually do this example and any of the rest on the page, I want to remind you that we're just creating the systems or interpreting them today. We don't know how to solve them yet. That is fine, okay? That's totally not a big deal. We are going to learn several methods on how to solve starting next lesson. Okay, today we're just looking at the systems, creating them, and then on the previous page we looked at whether a specific point was a solution or not. Okay, so let's start here. So we have two people in this example, and those are my nieces, Adelie and Everett. Okay, and we have also some information here, knowing that 1 year ago Adelie was twice Everett's age and that currently she is 2 years older than Everett. Okay, so let's start with making some variables. Okay, so I chose, okay, there we go. Let A represent Adelie's current age. Okay. And usually we would not let E be a variable in a question. So I usually wouldn't choose that, but it's kind of the best choice for this particular problem. And also, since we're not actually doing any solving with it, it's not going to get confusing in that sense. If you're wondering why, we did talk about this earlier in the year, but the letter E in math represents a number. It's like how pi represents a number. So we usually don't use it as a variable, but in this case, just for the example, it's fine. We're not doing any solving with it, but in the future, I wouldn't choose E as a variable. That being said, if you did choose E as a variable, I'm not going to punish you for it. It's just like kind of mathematically, the convention is to not choose E, but it's like fine if you do. It's like not like the biggest deal. Okay, so now that we have two variables, we're going to make two equations. Okay, so we know that Adelie is currently 2 years older than Everett. Okay, so we're going to say that Adelie, her age right now is equal to Everett's age plus 2, right? Because she's 2 years older than Everett. So if you added 2 to Everett's age, then they would be the same. So that's their right now ages. Okay, so you can make yourself a note. Okay, and I would, especially because this is kind of new to us, that this is the equation that represents their ages today. Okay, you don't need to make yourself that note, but just when you look back on these notes, that'll probably be helpful. Okay, and then we also know that 1 year ago, okay, Adelie was twice Everett's age. So let's start with the 1 year ago part, and then we'll worry about the twice part. Okay, so if we're talking about 1 year ago, then each child, each girl, Adelie and Everett, were 1 year younger than they are right now. Okay, so and to show that their age is 1 year younger, if we took their current age and subtracted 1, that would be 1 year younger, right? Current age minus 1 means a year younger. And so Adelie will be 1 year younger in this equation, and Everett will also be 1 year younger. Okay, so that's why we have minus 1s. Okay, it's because it's their current age take away 1 year to show that we're talking about last year or 1 year ago. And last year, Adelie was twice Everett's age, okay? So if we multiplied Everett's age by 2, that would be equal to Adelie's age. Okay, so that's the equation that we would get out of that. And again, you can make a note if you would like that this is their ages last year. Okay, I went through that one a little bit slowly. That was on purpose because this is the first time we've been doing this. The next one I'll go a little bit more quickly, but if you need more clarification, just let me know. Okay, so a company had to pay $596 in wages to 2 of its employees who worked a total of 46 hours that week. Okay, so I'm going to start highlighting some important information here as I read. One employee makes $14 an hour and the other makes $11 an hour. Determine a system of equations that can be used to find the number of hours each employee earned. That's supposed to say worked. Sorry, you guys. Let's correct that. Doesn't make any sense otherwise. Okay, so we are going to start with our let statements. Okay, so we have 2 employees, right? 2 employees in this question. So I'm going to choose A to represent. That's not how you spell. There we go. Represent the first employee. Maybe I'm going to write that a little bit differently. To represent employee number 1. Let's put it that way. Hours worked. Okay, and we're going to let B represent employee 2's hours worked. Okay, the reason I'm choosing that phrasing, like that those variables represent those things, is because we're talking about, in the whole question, hours worked, right? The whole question has to do with how long these 2 people worked and how much they got paid for those hours that they worked. So that's kind of what the question is based on, so that's how I chose my variables. Okay, then we're going to make our 2 equations. So we have 2 things going on here, right? We have first the hours that they worked, and second how much they got paid for them. So we know we're going to have 1 equation to represent each of those 2 things. Okay, so first I'm going to talk about their hours worked, and we know that if we add up A and B, so that's how many hours employee 1 worked plus how many hours employee 2 worked, we know that from the question it means they worked a total of 46 hours. Okay, it says that right there. And so we know that when we add up the hours, each employee worked, it's going to add up to 46. Okay, so again, if you want to make yourself a note here, not a bad idea. Total hours worked. Okay, and the second equation is going to have to do with how much they got paid. So the first thing we know is that they earned $596 in wages. Okay, so whatever we add up is going to add up to 596. That's the first thing we know. And the second thing we know is that they have hourly wages here in the middle of the question. Okay, so we know how much each of them makes per hour. So if we were to take employee 1's wages represented by A, we know that person makes $14 an hour. So we're going to multiply it by 14. That would give you how much they got paid, right? If you take the number of hours you work and you multiply it by the hours that you worked. Oh my goodness. You guys, I'm sorry. I'm having a hard time talking today. If you take the number of hours that you work and you multiply by how much you make per hour, that will tell you how much money you earned, right? So that's what I'm doing here. Number of hours worked multiplied by how much you make per hour. Okay? And then second employee, same thing, right? So we know that the second employee also worked a number of hours and that person makes $11 an hour. So if I multiply that person's hours worked by their wage, then that'll tell us how much they made in total. And then we know that when you add both of those amounts up here, it gives us $596. Okay, that's given in the question. And so that would be the total amount paid, or total money paid, I guess. Okay, so there we go. Now we have 2 equations with 2 variables. There we go, we can move on. Okay, so a bicycle has 2 wheels and a tricycle has 3 wheels. That's true. Interpret the system of equations below. Okay, so in this system of equations, we can see that there are already equations made for us, but they didn't define the variables, and we're going to want to figure that out. Now, the first thing we can presume with some certainty, or like with a good guess, is that we're talking about a bicycle. It's probably represented by B. We're talking also about a tricycle. You can probably guess that's represented by T, right? So we can write that out. B represents bicycle. That's not how you spell, Mrs. Reason. My goodness, there we go. Okay, and T is tricycle. Now, let's look at that equation where I made those marks. B plus T is equal to 30. So if we are talking about bicycles plus tricycles equals 30, then we're saying that the number of bicycles plus the number of tricycles is equal to 30. Okay, so you can say in total, oh boy, there are 30 bicycles and tricycles. Okay, so again, since B is representing bicycle and T is representing tricycle, if you take the number here, oh boy, B plus T is equal to 30. We're saying that in total there are 30 of those items, bicycles and tricycles. And then the first equation, if you take a look there, so if we're talking about 2 times B plus 3 times T, so where are we seeing the numbers 2 and 3 as well is what we want to ask ourselves. What do those numbers mean? What significance do they have? So if you take a look in the question, we see that a bicycle has 2 wheels, and conveniently 2 and B are paired together, and a tricycle has 3 wheels, and conveniently 3 and T are paired together. So we are probably talking about the number of wheels for each item. Okay, so that's what we're probably looking at here. So we can make a statement that the number of wheels on the bike plus the number of wheels on the trikes add up to 80. Okay, so if you multiplied 2 by the number of bicycles, that would give you the number of wheels of all the bicycles, plus 3 times the number of tricycles would give you the number of wheels on all the tricycles, and together they add up to 80. Okay, so we can say there are 80 wheels in total on the bicycles. Ooh, yikes. Bicycles and tricycles. Okay, I know that one can be a little challenging for some people. This is definitely one of those things that's easier to teach in person, but I did my best to try and explain it. Watch this video a couple times if you need to. There's no problem with that. But if you have to message me, you have questions, of course there's no problem with that. You guys know that. So let me know whatever you have questions about, and we can talk about it, okay? And I don't actually have a really good worksheet for this yet, but I'm going to try and make one, okay? And then in the next video, there will be the next lesson. Yeah, okay. So I will see you guys in the next video. Okay, take care.